Please welcome the VP of Amazon Machine Learning, Dr. Swami Sivasubramanian.
Hello, welcome to the second week of reInvent. It has certainly been an exciting event so far, with so many groundbreaking launches, a record-breaking toast to kick off the event, and tons of sessions to attend so far. And last week, over 200,000 viewers tuned in to watch the first ever virtual live races during the AWS Deep Racer League reInvent Championships on Twitch. You will also have the opportunity to hear from our experts and many customers such as NASCAR, McDonald's, Mobileye, Intuit, and PwC in more than 50 machine learning sessions taking place during the event. I love seeing the enthusiasm for machine learning among our customers. It is a testament to the technology's potential to change businesses and industries for the better. Machine learning is one of the most disruptive technologies we will encounter in our generation. More than 100,000 customers use AWS for machine learning today, right from creating a more personalized customer experience to developing personalized pharmaceuticals. These tools are no longer a niche investment. Our customers are applying machine learning to the core of their business. Now, let's take a look at some examples. Domino's Pizza uses machine learning for predictive ordering to help meet its goal of delivering hot, fresh pizzas in 10 minutes or less following an order. Roche, the second largest pharmaceutical company in the world, uses Amazon SageMaker to accelerate the delivery of treatments and tailor medical experiences. Cabbage, an American Express company, applied ML to their loan application process and surpassed major US banks to become the second largest business payment protection program lender in the country, preserving an estimated 945,000 jobs across the US. The BMW Group is using Amazon SageMaker to process, analyze, and enrich more than 7 petabytes of data in order to forecast the demand of both model mix and individual equipment on a worldwide scale. Using Amazon SageMaker, Nike built a product recommender on Nike.net to deliver a more relevant shopping experience to its wholesale customers. And finally, in sports, Formula One applies machine learning to their car design process, giving them new insights into more than 550 million data points collected through more than 5,000 single and multi-car simulations. As you can see, our customers are innovating virtually in every industry. So why do our customers choose us? They choose us because of our depth and breadth of services and the rapid pace of innovation. So now let's take a look at our machine learning offerings. At the bottom layer of the machine learning stack, we provide ML capabilities for expert machine learning practitioners. These include optimized versions of the most popular deep learning frameworks, including PyTorch, MXNet, and TensorFlow. And we provide choice in infrastructure across GPUs, CPUs, and our own silicon innovation in training and inference as well. At the middle layer of the stack, we have Amazon SageMaker, which allows developers and data scientists to build, train, and deploy machine learning models at scale. SageMaker includes a broad set of capabilities, many of which are both novel and unique to AWS. And these services are available through an integrated development environment for machine learning, which we call SageMaker Studio. Many organizations are standardizing on SageMaker to remove the complexity from each step of the ML development workflow so that it's faster, more cost-effective, and easier to do. At the top layer are our AI services, where we are helping customers adopt machine learning without having to build their own models from scratch. In vision, we have recognition, and in speech, we provide text-to-speech with Poly and speech-to-text with Transcribe. And customers can create their own chatbots with Amazon Lex. For text, we provide natural language processing with Comprehend, translate for translation, and TextRank to extract structured text from documents and images. We have also applied Amazon's more than 20 years of experience in machine learning to deliver services, including Amazon Personalized for personalized recommendation, Amazon Forecast to automatically create custom demand forecasts, and Amazon Fraud Detector to identify online fraud. We have also built end-to-end solutions, including Contact Lens for Amazon Connect for contact center analytics, Amazon Kendra for enterprise search, Amazon Code Guru for automated code review, and DevOps Guru to improve application availability. And last week, we introduced services that are custom-built for industrial sector. As you can see, we are innovating really fast and at a rapid clip to meet the needs of our customers. 4 years ago, at re:Invent 2016, we launched our first AI services, Poly, Lex, and Recognition. Since then, we have launched hundreds of features, including Amazon SageMaker and 11 new AI services, with 6 more launched just last week. This year alone, we have already launched more than 250 features, and we have delivered over 200 features each year for the past 3 years. That's a really big deal for a new area of technology which is moving so rapidly. As you can see, we are building the most comprehensive set of machine learning products because giving our customers the right tools to invent with machine learning is necessary to unlock the power of this technology. 15 years ago, when I was making the transition to my first job out of grad school, I noticed that builders were being held back by their technology. Instead of bringing their ideas to fruition, they were waiting on IT departments to procure the necessary hardware or software to build their applications. Shortly after I started at AWS, I had the fortune to be part of the launch of some amazing technologies like Amazon S3, RDS, Dynamo, and saw how it transformed every industry as builders finally had the right tools to do their jobs. It's no exaggeration to say that cloud computing has enabled various startups and businesses to achieve a new level of success. Today, machine learning has reached a similar moment. Until recently, it was only accessible to the big tech firms and cool startups that had the resources needed to hire experts to build sophisticated ML models. But freedom to invent requires that builders of all skill levels can reap the benefits of revolutionary technologies. And the technologies themselves allow for experimentation, failures, and limitless possibilities. So today, we are enabling all builders, irrespective of the size of their company or the skill level, to unlock the power of machine learning. And through feedback from our customers and our own experience implementing machine learning at Amazon, we have learned a lot about what it takes to create an environment that promotes boundless innovation. At Amazon, we often use tenets or principles to follow as guides for teams or projects. Today, I'm going to talk through some of the tenets that enable freedom to invent. We will also share more about the work we are doing to give builders the power to harness machine learning along the way. So let's start with the very first thing you will need, firm foundations. To enable more builders to build and deploy machine learning, we are focused on optimizing the very foundations that these models are built upon, frameworks and infrastructure that is used to speed up the process of training and deploying these models and reducing costs. Firm foundations are essential to giving builders the freedom to invent. With the abundance of compute power and data available today, machine learning is doing some incredible things. Things that we never thought were possible before, like self-driving cars, autonomous systems, or machines that understand what we are saying. Often, these more advanced applications of machine learning use deep learning, which consume massive amount of inputs to achieve their high accuracy. The complexity of the model and the size of training data set means that building a deep learning model can be resource intensive and can take days or even months to train. Moreover, there is not a single framework that is universally used by all our expert machine learning practitioners. They typically build on 3 primary frameworks for deep learning: TensorFlow, PyTorch, and MXNet. We know that choice is important to our customers. That is why we invest in making AWS the best place to run all of the major deep learning frameworks. Through our deep learning containers and deep learning Amazon machine images, we ensure customers always have the latest versions of the major frameworks optimized to run on AWS. Today, 92% of cloud-based TensorFlow and 91% of cloud-based PyTorch runs on AWS. And we actively participate in the community to add new functionality to these frameworks. For example, TorchServe, now the default model serving library on PyTorch, was built and is maintained by AWS in partnership with Facebook. We are also expanding the usage of deep learning to new audiences and widening the available talent pool with projects like Deep Java Library, an open source toolkit for performing deep learning in Java. In addition to optimizing frameworks, a critical part of being able to efficiently deploy all machine learning models, such as deep learning, is the underlying infrastructure. Now, every machine learning project is different, with different compute needs. And we have built the broadest and deepest choice of compute, networking, and storage infrastructure to help our customers meet their unique performance and budget needs. We are rapidly investing in this area to keep up with the growth of machine learning sophistication, introducing new chips and instances that help our customers keep the cost of training and inference down while speeding up their innovation. The latest addition to our portfolio to help builders train faster and more cost-effectively is the P4D instances, which provide the highest performance for ML training in the cloud. They feature the latest NVIDIA A100 GPUs and first in the cloud 400 gigabit per second networking. For inference, we launched AWS Inferentia-based EC2 Infon instances. They provide the lowest cost per inference in the cloud, up to 45% lower cost or 30% higher throughput than comparable GPU-based instances. After migrating the vast majority of inferences to Infon, the Amazon Alexa team saw 25% lower end-to-end latency for the text-to-speech workloads. And customers such as Snap, Finra, Autodesk, and Condé Nast use Infon instances to get high performance and low-cost ML inference. Condé Nast, for instance, observed a 72% reduction in cost than the previously deployed GPU instances. Together, this powerful hardware and optimized frameworks provide firm foundations for innovation in machine learning. For training, last week, Andy announced 2 new efforts. The first is Habana-based Amazon EC2 instances. Habana Gaudi accelerators from Intel will offer 40% better price performance over current GPU-based EC2 instances for training deep learning workloads. They will be available the first half of 2021. The second is AWS Trainium, a machine learning training chip custom designed by AWS for the most cost-effective training in the cloud, coming in 2021. We are building Trainium specifically to provide the best price performance for training machine learning workloads in the cloud. Now, our customers tell us they need more than just the best hardware to train large models. For example, let's take a look at 2 deep learning models that are highly popular. Mascar CNN is a state-of-the-art computer vision model used by our customers for things like autonomous driving. It requires a significant amount of training data. Similarly, T5 is a state-of-the-art natural language model with 3 billion parameters. To speed up training for both of these, we can use distributed training. To speed up training times for models with large training data sets, like Mascar CNN, you can split your data sets across multiple GPUs, commonly known as data parallelism. When training large models like T5, which are too big for even the biggest, most powerful GPUs, you can write code to split it across multiple GPUs, commonly known as model parallelism. But doing this is difficult and requires a high level of expertise and experimentation, which can even take weeks, even for expert practitioners. So we asked ourselves, how can we make it easier for our customer to do distributed training, do it well, and do it really fast? Today, I'm excited to announce, with only a few lines of additional code in your PyTorch and TensorFlow training scripts, Amazon SageMaker will automatically apply data parallelism or model parallelism for you, allowing you to train models faster. Data parallelism with Amazon SageMaker allows you to train 40% faster. Similarly, with model parallelism, what used to take a dedicated research lab, weeks of effort, and hand-tuning training code now takes only a few hours. So what does this mean for our customers? Using these engines, we challenge our teams that work on TensorFlow and PyTorch to train Mascar CNN and T5 as fast as possible. Here is what happened. Last year, we shared that AWS had the fastest training for Mascar CNN at 28 minutes on TensorFlow and 27 minutes on PyTorch. With our optimization, we cut the training time by approximately 75% to 6 minutes and 13 seconds for TensorFlow and 6 minutes and 45 seconds for PyTorch. Our TensorFlow training time is 23% faster than the previous fastest published record training time held by our friends in Mountain View. And with our optimizations such as model parallelism on T5, we went from development to fully trained model on PyTorch in less than 6 days. It is the fastest published training time for this model. Previously, this would have taken weeks of developer time to find the optimal way to split the model. We are very excited about the innovations we are bringing to builders in this area. But deep learning is still the domain of expert practitioners and is simply too hard for most people to do. That leads to my second tenet. For any technology to have significant impact, builders need to be given the shortest possible path to success. Having the tools for your builders to be able to satisfy and explore their ideas quickly without barriers is a significant accelerator to your business. Historically, machine learning development is a complex and costly process. There are barriers to adoption at each step of the ML development workflow, right from collecting and preparing data, which is time-consuming and undifferentiated, then choosing the right algorithm, which is often done by trial and error, leading to lengthy training times, which leads to higher costs. Then there is model tuning, which can be a very long cycle and require adjusting thousands of different combinations. Once you have deployed a model, you must monitor it and then scale and manage it in production. To make things more complicated, many of the tools developers take for granted when building traditional software, such as debuggers, project management, collaboration, and so forth, are disconnected when it comes to machine learning development. To address these barriers, in 2017, we launched Amazon SageMaker. We built Amazon SageMaker from the ground up to provide every developer and data scientist with the ability to build, train, and deploy ML models quickly and at lower cost by providing the tools required for every step of the ML development lifecycle in one integrated, fully managed service. In fact, we have launched more than 50 SageMaker capabilities in the past year alone, all aimed at making this process easier for our customers. The customer response to what we are building has been incredible, making Amazon SageMaker one of the fastest growing services in AWS history. And tens of thousands of customers are using Amazon SageMaker today. It's customers from virtually every industry, including financial services, healthcare, media, sports, retail, automotive, and manufacturing. These customers are seeing significant results from standardizing their ML workloads on SageMaker. Let's take a look at some of them. Lyft's Autonomous Vehicle Division Level 5 reduced model training time from days to hours. T-Mobile saved data scientists significant time labeling thousands upon thousands of customer messages to improve customer service by using SageMaker Ground Truth. Vanguard deploys workloads up to 20 times faster using SageMaker. iFood, the leader in online food delivery in Latin America, uses Amazon SageMaker to optimize delivery routes to decrease their distance traveled by their delivery partners by 12%. The scale at which iFood operates, 12% is a big deal. And ADP reduced time to deploy machine learning models from 2 weeks to just 1 day. As you can see, so many customers are able to innovate more quickly by using SageMaker. Another customer that has done some really fascinating things with machine learning is NFL. We started working with NFL to create next-gen stats as a new way to engage fans. And we have expanded that work recently to their player health and safety initiative. To talk more about this and how the NFL is expanding its use of machine learning with SageMaker, I'd like to introduce Jennifer Langton of the NFL.
My name is Jennifer Langton. I'm Senior Vice President of Health and Innovation for the National Football League. While sports is my profession, it's always been a central part of my life. In my second year as a college athlete, a knee injury took me off the field. And what was at that time one of the greatest challenges I had ever faced became inspiration for my career. I know personally the impact an injury can make on an athlete's life and also what an impact technology and innovation can have in treating injuries and preventing them before they happen. In our work at the NFL, our highest priority is the health and safety of our players. We leverage data and innovation in order to protect our players and make our game safer. The NFL has used AWS as its official cloud computing and machine learning provider for the NFL Next-Gen Stats platform since 2017. Next-Gen Stats provides real-time location data speed and acceleration for every player during every play on every inch of our fields. Powered by AWS, Next-Gen Stats enhances the fan experience. At reInvent last year, we built on that successful platform with the announcement of a new expanded partnership, a partnership that will pursue an audacious goal, making the sport of football and ultimately all sports safer for athletes who play them. We will combine unique data sets of human performance and football information, including hours of video, with AWS's strong culture of technology innovation to develop a more profound understanding of our game and human performance than has ever been done before. Our goal is to improve player safety by eventually being able to predict and therefore prevent injury. AWS's AI and machine learning services, combined with the NFL's data, will speed an entire generation of new insights into player injuries, game rules, equipment, rehabilitation, and recovery. But before we talk more about where we're going together, let me first share where we've been in our innovation journey as a league, showing just how much we've accomplished in a short amount of time. Over the past 6 years, biomechanical engineers, jointly appointed by the NFL and the NFL Players Association, have analyzed on-field injuries and developed laboratory tests for helmets that represent the impacts which cause those injuries on field. This work has been central in informing everything from our rules changes to improve protective equipment, two centerpieces of our efforts to reduce injuries, specifically concussions. Using video of head impacts, our biomechanical engineers developed a test that accounts for hundreds of different variables: speed, direction, who makes contact with who, play type, and impact, among others. We use it to test the performance of the helmets NFL players wear, and then we create a simple, color-coded chart with the best performing helmets in the darkest green and the worst, which are prohibited, in red. This has led to a tremendous behavioral change among NFL players over the last 5 seasons. We've gone from having about 1/3 of players in top-performing helmets to nearly 100%. Moving players into better performing equipment, encouraging safer tackling techniques, and rules changes, all three underpinned by data and innovation, together have led to significant progress in keeping our players safe on the field. As a result of this three-pronged injury reduction plan, we saw a 24% drop in reported concussions during the 2018 season. And the 2019 season saw reported concussions remain at that lower rate. This validated our intervention. That's what we mean when we talk about our key drivers, data and innovation, that have evolved the game and will continue to evolve the game. And AWS is helping us to do that. As a part of our work together, we are developing the digital athlete, a computer simulation model of a football player that can be used to replicate infinite scenarios within our game environment, including variations by position and even environmental factors. By simulating different situations within a game environment, our goal is to better foster an understanding of how to treat and rehabilitate injuries in the near term, and eventually predict and prevent injuries in the future. Leveraging video and next-gen stats data, we together are doing something that has never been done in football before. Developing computer vision models that identify the forces that cause concussions, among other injuries. Using Amazon SageMaker, we are in the early phases of training deep learning models to identify and track a player on field, an important first step as we train the system to detect, classify, and identify injury-significant events and collisions. In the case of our helmet example, the volume of new data the system generates and the speed with which we can incorporate that new data into our helmet testing and analysis could exponentially expand our ability to rank, develop, and ultimately encourage player adoption of better performing helmets. And over time, the techniques developed to detect and prevent concussions will also be extended to reduce a wide range of injuries, including foot, ankle, and knee injuries. This technology is giving us a deeper understanding of the game than ever before, allowing us to reimagine the future of football. We just launched a challenge to pressure test the solutions that the NFL and AWS are creating together. The crowdsourced computer vision challenge is currently underway and allows anyone with the interest and capability to be a part of our important work. The data and insights collected through this project have the potential not only to revolutionize football, but also to help address injury prevention and detection beyond the football field to society more broadly. Last year, the NFL celebrated its 100th season, and we look forward to the next 100 years of football. We remain committed to innovating on behalf of our players and those that come after them. I'm so proud of the work we are doing together to that end. The future of football, together with AWS, is very bright.
Thanks, Jennifer. It really amazes me to see the impact that SageMaker can have in helping our customers embrace machine learning as a core part of their strategy. And as it becomes easier for our customers to build, train, and deploy one model, they are inevitably going to do more of it. Take Intuit, for example. Intuit was one of our very first SageMaker customers. They started with a machine learning model to help customers make the most of their tax deduction. And today, ML has become a core part of their business, touching everything from fraud detection to customer service to personalization to the development of new features within their products. Just in the last year alone, they have increased the number of models deployed across their platform by over 50%. This increased use of AI and ML drove a variety of customer benefits, including saving customers 25,000 hours with self-help and cutting expert review time in half, improving customer confidence. And it's not just Intuit. We see this across many of our customers. Many of them today are looking to scale to hundreds or even thousands of models in production. And at this scale, bottlenecks in ML development, whether it's data prep, training, and many more, they become more amplified and new challenges arise. So we needed to build new tools across the entirety of the machine learning workflow to help with not just one model, but with hundreds or even thousands of models. So I'm going to walk through these tools today, some of which we launched last week and some that are new today. Let's start with data prep, the first step of building a machine learning model. It is a time-consuming and involved process that is largely undifferentiated. And we hear from our customers that it constitutes up to 80% of the time spent in ML development. Last week, we announced Amazon SageMaker Data Wrangler, a game-changing way to do ML data prep much faster than through a visual interface in SageMaker Studio. Typically, to get data ready for a machine learning model, you need to collect data in various formats from different sources, which may require you to create complex queries. With data wranglers, you can quickly select data from multiple data sources, such as Athena, Redshift, Lake Formation, S3, and SageMaker Feature Store. Previously, you would then need to write code to transform your data. But with Data Wrangler, we provide 300 plus pre-configured data transformations. So you can transform your data without writing a single line of code. Next, once the data is transformed, it's easy to clean and explore the data with data visualizations in SageMaker Studio. These visuals allow you to quickly identify inconsistencies in data prep workflow and diagnose issues before models are deployed in production. Finally, rather than having to engage an IDOps team to get your data ready for production, you simply export your data prep workflow to a notebook or a code script with a single click. Now, not only will SageMaker Data Wrangler integrate with AWS data sources, but coming soon, you'll be able to quickly select and import data directly into SageMaker from Snowflake, Databricks, Delta Lake, and MongoDB Atlas. Using SageMaker Data Wrangler, with just a few clicks, you can complete each step of the data prep workflow and easily transform your raw data into features. Talking about features, in machine learning, features represent relevant attributes or properties that your model uses for training or for inference where you make your predictions. Now, to explain it a little bit more, let's take a look at Intuit, for example. In their TurboTax contextual health model, which tries to provide the most relevant possible tax guidance to a tax filer, the features the model might use can include information like what step you are in the tax filing process and your prior year's tax returns. Intuit uses features in large batches to train its model, and at inference, so they need to be available in real time to make fast predictions. Previously, Intuit was storing features for batch training in one data store and the real-time features in another. This means it required months of coding and deep expertise to keep these features consistent. So Intuit came to us with this challenge, and together we worked backwards from the problem to build a feature store, which served as a training repository for features where latency isn't as important, and also provide access to the exact same features at runtime where latency is important. It also enabled feature discoverability and reuse, accelerating the model development lifecycle and improving data worker productivity. To solve this problem for all of our SageMaker customers, last week we launched SageMaker Feature Store. You can securely store, discover, and share features so you don't need to recreate the same features for different ML applications. This saves months of development effort. Now, Feature Store serves features in large batches for training and also serves features with single-digit millisecond latency for inference. And it does all the hard work of keeping these features in sync and consistent. You can use visuals to search your features and share and collaborate with other members in your organization. Now, as you can see, SageMaker Data Wrangler and Feature Store make it easier to aggregate data and prepare and store features. This is an important part of the machine learning process because your model's predictions are only as good as the data and features that it uses. That's also why we need to better understand the bias in the data our models use and why our models make a certain prediction. But today, it's very hard to get this visibility. It requires a lot of manual effort and stitching together a bunch of open source solutions. So our customers asked us to make this process easy for them. Today, we are launching Amazon SageMaker Clarify, which helps improve your ML models by detecting potential bias across the machine learning workflow. To talk more about the work we are doing here, I'd like to welcome Dr. Nashley Cephas, one of our leaders at AWS focused on algorithmic bias and fairness.
Thank you, Swami. I have been immersed in machine learning technologies as both a scientist and a consumer. And I have developed a personal passion for mitigating bias in technology and identifying potential blind spots. As one of the scientists working on bias and fairness at Amazon, I see firsthand the challenges in doing this and the increasing need for us to get it right. Mitigating model bias and understanding why a model is making a prediction helps data scientists create better machine learning models. And it helps the consumers of machine learning predictions make better decisions based on that information. Bias can show up at every stage of the machine learning workflow. So even with the best possible intentions and a whole lot of expertise, removing bias in machine learning models is difficult. Bias can come in at the very beginning, from the training data itself, when it's not representative. For example, not having enough dramas in your training data for a TV show recommendation model may bias the outcome. You could also introduce bias through an imbalance in training data labels and by selecting a subset of that training data. And then you can also have bias through model drift, where your model is making predictions using data which is sufficiently different from the data on which it is trained. For example, a substantial change in mortgage rates could cause a home loan model to become biased. Today, the process to get insights into data bias across the machine learning workflow is tedious for both data scientists and machine learning developers. I have spent my career working on this problem, and it's hard to do. I'm excited to present a product feature that I've been a part of from day one of its inception, SageMaker Clarify. SageMaker Clarify provides an end-to-end solution to help you mitigate bias in machine learning and provide transparency across the entire machine learning workflow. And it all works within SageMaker Studio and integrates with other SageMaker tools throughout the process of building a model. Let's take a look at how it works. To start, during your initial data preparation in SageMaker Data Wrangler, SageMaker Clarify enables you to specify attributes of interest, such as location or occupation, and then it runs a set of algorithms to detect the presence of bias. SageMaker Clarify then provides a visual report with a description of the sources and severity of possible biases so that you can take steps to mitigate. After you've trained the model on this data, Clarify will check the trained models for imbalances, such as more frequent denial of services to one group over another, and provide you with a visual report on the different types of bias for each attribute. With this information, you can then go back and relabel data to correct any imbalances. Once your model is deployed, you can get a detailed report showing the importance of each model input for a specific prediction. This can help the consumer of your machine learning model better understand why a model is making a certain prediction. For instance, a business analyst wanting to understand what is driving a demand forecast prediction. Lastly, while your initial data or model may not have been biased, changes in the real world may cause bias to develop over time. SageMaker Clarify is packaged with SageMaker Model Monitor so that you can get alerts to notify you if your model begins to develop bias or if changes in real-world data can cause your model to give different weights to model inputs. This way, you can retrain your model on a new data set. Reducing bias will continue to be a challenge in machine learning, but SageMaker Clarify provides tools to assist in these efforts. Thank you.
Thank you, Nashley. We are really excited to bring this important feature to our customers. As customers scale machine learning, managing time and cost is critical. And while data prep constitutes a large part of the time to build machine learning models, training a machine learning model on that data can be a costly process at scale. So data scientists and machine learning practitioners want to naturally maximize their resources. Now, if you look at training itself, it has different phases like data pre-processing, training, and finalization. And one potential bottleneck in optimizing your resources can be when your data pre-processing ends up being compute intensive and your CPU core is busy, while the GPU, which is used for training phase and is the most expensive resource in your system, sits there idling, underutilized. But today, there isn't a standard way to identify these bottlenecks like there is in software development with profilers. So customers today need to cobble together a diverse set of open tools. Many of them are unique to their ML framework they are using. To address this, last year, we started with introducing SageMaker Debugger, which automatically identifies complex issues developing in ML training jobs. Now, customers wanted to use Debugger to get more detailed profile information to optimize their resources. Today, we are adding a new capability to SageMaker Debugger to provide deep profiling for neural network training to help identify bottlenecks and maximize resource utilization for training. With deep profiling for Debugger, you can visualize different system resources, including GPU, CPU, network, and I/O memory within SageMaker Studio. With this information, you can analyze your utilization and make changes based on the recommendations from the profiler or on your own. You can profile your training runs at any point in the training workflow. SageMaker Debugger saves developers valuable time while reducing costs. Now, as you can see, ML comprises multiple steps, some which take place in sequence and others in parallel. And there is a lot that goes on in stitching these workflows together. In traditional software development, continuous integration and continuous deployment, CI/CD pipelines, are used to automate the deployment of workflows and keep them up to date. But in machine learning, CI/CD style tools are rarely used because where they do exist, they are super hard to set up, configure, and manage. To address this, last week we launched Amazon SageMaker Pipelines, the first purpose-built, easy-to-use ML CI/CD service accessible to every developer and data scientist. With just a few clicks in SageMaker Pipelines, you can create an automated ML workflow that reduces months of coding to just a few hours. SageMaker Pipelines takes care of the heavy lifting involved with managing dependencies and tracking each step of the workflow. Now, pretty much anything you can do in SageMaker, you can add to your workflow in pipelines. Moreover, these workflows can be shared and reused within your organization as well. Templates for model building and model deployment pipelines help you get started quickly. And once created, these workflows can be easily visualized and managed in SageMaker Studio, so you can even compare your model performance. Now, to show you how all of these new features work together, I'd like to invite Dr. Matt Wood to the stage for a demo.
Thank you, Swami, and good morning. With capabilities like Data Wrangler, Feature Store, Clarify, pipelines, and new debugging and profiling features, it's never been easier to build, train, and deploy machine learning models in Amazon SageMaker. By working together, these capabilities provide a way for developers and data scientists to focus on what really matters, building accurate, high-quality machine learning models which improve over time without all of the undifferentiated heavy lifting. SageMaker removes the muck of building machine learning models and leaves only the diamonds. So what goes into a great model? Let's take a look at building a model which uses track and artist information to create the perfect musical playlist. First, you need data, lots of data, and lots of different types of data. The more, the merrier. SageMaker lets you connect and load your data from sources such as S3 and Redshift in just a few clicks from SageMaker Studio. SageMaker can then use this data to train a model. Models learn complex and often subtle patterns to let you map inputs to predicted outputs. So we'll need tons of metadata about the songs in our library, length, beats per minute, genre, ratings, and more to use as our inputs. Next, we'll need a strong set of features. Data in its raw form, it usually doesn't provide enough or optimal information to train a great model. And so to maximize the signal and reduce the noise in the data, we need to convert and transform it into features through a process known as feature engineering. For instance, beat and genre could be combined into a more abstract or super feature called danceability. Now, creating features can take a ton of time. Some customers estimate that it's about 80% of the time spent building machine learning models. Instead, we can use Data Wrangler to convert, transform, or combine raw tabular data into features in a fraction of the time without writing a single line of code. With a single click, we can then save these features to the SageMaker Feature Store, which lets us check in and check out features in a very similar way as you would a source code repository. The service lets us create multiple versions of features, and we can add descriptions and search our features, which helps teams understand and reuse them for other models. You can retrieve an entire data set for training, or, once your model is deployed, retrieve individual features used in making low latency predictions, such as predicting that I want to listen to more songs with high danceability like ABBA's Dancing Queen, all with single-digit millisecond latency. There's no need to try to recompute these features on the fly over and over again. You can just do it once in Data Wrangler and use them again and again from the feature store. Next, great models can be used in many different situations if they are trained on a balanced set of features and data. We're going to use SageMaker Clarify to ensure that our training data is well balanced. And that means that it has the possible values of features and label are well represented across the data, and that the accuracy of our trained model is roughly the same across different subsets of the data, such as different musical genres. For example, if we had a preponderance of blues music in our training set, our model would probably create a lot of blues playlists. That's fine if all you want to do is listen to the blues. But our model will be even more useful if we use an evenly balanced set of features representing dozens of different genres for training. So here, we can make sure that that is the case. and that our model makes good predictions with good coverage across a wide range of musical genres. We can also use Clarify to inspect every single prediction to understand how each feature plays a role in that prediction. This allows us to check that our model isn't overly reliant on features which we know to be underrepresented in our data. Now, one of the great things about machine learning is that models can improve over time, not just based on new data as it becomes available, but also by incorporating the learnings we see from tools like Clarify and the new debugging and profiling features to systematically identify sources of error or slowness and remove them from our model. With this approach, we can condense hundreds of thousands of hours of real-world experience into just a few retraining iterations, and our models can improve far more quickly. And since we often want to continually improve our model by rebuilding it over and over again, we can take advantage of the automation in pipelines, the new continuous integration and continuous deployment capability in SageMaker, which lets us automate the entire end-to-end machine learning build process and replay it perfectly with a single click. This not only accelerates the time to our first model, but it decreases the time between model improvements and gets us to better models more quickly. So in SageMaker, we have made the tools which every developer is familiar with: visual editors, debuggers, profilers, and CI/CD, all wrapped into an integrated development environment available for machine learning. And we can't wait to see what you'll use SageMaker for next. With that, I'll hand it back to Swami. Thanks a lot.
Thanks, Dr. Wood. Another place where we are seeing a lot more machine learning happening is the edge. More and more applications, such as industrial robots, autonomous vehicles, and automated checkouts, require machine learning models that run on smart cameras, robots, equipments, and more. However, operating ML models on edge devices is challenging. This is because of limited compute, memory, and connectivity. It also takes months of hand-tuning each model to optimize performance. In addition, many ML applications require multiple models to run on a single device. For example, a self-navigating robot needs an object detection model to detect obstacles, a classification model to recognize them, and a planning model to determine the appropriate actions. Now, once a model is deployed in production, your model quality may decay because real-world data used to make predictions often differs from the data used to train the model, which leads to inaccurate predictions. In 2018, we announced Amazon SageMaker Neo to make it easier to deploy models on edge devices. While Neo addressed model deployment for a single model, developers still had to deal with managing models across a fleet of edge devices and also build mechanisms to monitor their performance and accuracy. This became harder for our customers as their ML edge adoption grew. And that is why we are investing more in this area to bringing the full power of SageMaker to edge devices. Today, we are excited to announce Amazon SageMaker Edge Manager. It provides model management for edge devices so you can prepare, run, monitor, and update machine learning models across fleets of edge devices. SageMaker Edge Manager applies specific performance optimizations that can make your model run up to 25 times faster compared to hand tuning. You can easily integrate Edge Manager to your existing Edge apps through APIs in common programming languages. And you can understand the performance of models running on each device across your fleet through a simple dashboard. Finally, Edge Manager continuously monitors each model instance across your device fleet to detect when model quality declines. With these services, we are delivering the most complete end-to-end solution for ML development with Amazon SageMaker, all integrated in one pane of glass with SageMaker Studio. While tools like SageMaker make machine learning model building and scaling more accessible to data scientists and developers, with machine learning skills, there are many more people who either lack the skills or the time to build models. But they can benefit from the insights that only machine learning can provide. As you all know, good ideas can come from anywhere in the organization. So we need to invest in making machine learning more available to more builders. And one of the ways we do this today is through SageMaker Autopilot. Building machine learning models historically has traditionally required like a binary choice. On one end, you can manually prepare the features, select the algorithm, and optimize model parameters, and have full control of your model design and understand all the thought that went into creating it. But this requires deep machine learning expertise. On the other end, if you don't have that expertise, you could use an automated approach to model generation with AutoML. But that provides very little visibility into how the model was created. Last year, we launched SageMaker Autopilot to address this trade-off. It automatically trains and tunes the best machine learning models for classification or regression based on your data while giving you full control and visibility so you can create your first model in minutes. With Autopilot, you just need to upload the training data. It automatically transforms the data in correct format for ML training. It then selects the best algorithm for the prediction you are trying to make, trains up to 50 different models, and then ranks them in a model leaderboard in SageMaker Studio so you can choose which model to use. Then you can deploy the model into production with a single click. No longer are developers left in the dark about how an AutoML model was built or the process in which it was created. Now, over the past year, we have invested in making Autopilot even more useful, increasing its accuracy by over 20% and reducing training time by 40%. While SageMaker Autopilot makes machine learning more accessible to ML builders and developers, there is a large group of database developers and data analysts who work in databases and data warehouses that still find it too difficult and involved to extract meaningful insights from that data. While they are SQL experts, they may not know Python and are reliant on data scientists to build the models for them so that they can add intelligence to their applications to derive insights. And even when they have a model in hand, there is a long and involved process to move data from the data source to the model and to build the application so that they can actually add intelligence to their apps. The result is that machine learning isn't being used as much as it could be. So we asked ourselves, how can we bring machine learning to this large and growing group of database developers and data analysts? We are bringing Amazon SageMaker and other ML services directly into the tools that database developers, data analysts, and business analysts use every day. These are databases, data warehouses, data lakes, and BI tools. Our customers use different types of data stores: relational, non-relational, data warehouses, and analytics services for different use cases. So we are providing a range of integration to give customers options for training their models on that data and adding inference results right from that data store without having to export and process that data. Now, let's start with relational databases. Our customers use Amazon Aurora as an efficient relational database for enterprise apps, SaaS, and web and mobile apps. Historically, adding machine learning from Aurora to an application was very complicated. It involved the data scientist building and training a model. Next, you had to write app code to read data from the database. Then you had to call an ML service to run the model. Then the output must be then reformatted to your application. And finally, you had to load the results into the app. This process is bad enough with a single database, but if you're using multiple data sources, like a customer database and an order management, then there is even more work and integration to be done. So to make it easier for customers to integrate machine learning into Aurora-powered apps, we launched Aurora ML, which makes it super easy to apply ML to apps right from the database just by using a SQL query. Let's say you wanted to conduct sentiment analysis or customer product reviews to identify negative feedback. No longer do you have to do all this multi-step process. You can simply run a SQL query, and then under the covers, Aurora passes the data to Amazon Comprehend, and then the results are then returned to Aurora, ready to be used. This integration makes it so much easier for relational database developers to apply ML. Now let's talk about data analysts. They often use Amazon Athena, an interactive serverless query service, to easily analyze data in Amazon S3 using standard SQL. And they want to apply ML to this data to generate deeper insights. To address this, we launched Athena ML. Customers can now use more than a dozen built-in ML algorithms provided by SageMaker directly in Athena to get an ML-based prediction for their data sitting on S3. Within seconds, analysts can run inferences to forecast sales, detect suspicious logins, or sort users into customer cohorts by invoking pre-trained ML models with simple SQL queries. So we have shown you how you can use pre-trained models in Amazon Aurora and Athena. But what if you didn't need to fuss with selecting a model at all? Every day, our customers use Amazon Redshift to process exabytes of data to power their analytics workloads. And customers want their analysts to leverage machine learning with their data in Redshift without having to deal with having the skills or the time to use machine learning. So we asked ourselves, how can we make this easy for our Redshift customers? Today, I'm really excited to announce Amazon Redshift ML, an integration of Amazon SageMaker Autopilot into Amazon Redshift to make it easy for data warehouse users to apply machine learning on their data. Let's see how it works. It starts with a simple SQL statement for creating a model. And once this SQL is run, the selected data is securely exported from Redshift to Amazon S3, and SageMaker Autopilot takes it from there. It performs the data cleansing and pre-processing, then creating a model and applying the best algorithm. All of the interactions between Amazon Redshift, Amazon S3, and SageMaker are completely abstracted away and automatically occur. Now, once the model is trained, it becomes available as a SQL function right in the customer's Redshift data warehouse. Customers can then use the function to apply the ML model to their data in queries, reports, and dashboards. So for instance, in our customer churn example, they can run the customer churn SQL function on new customer data in the data warehouse regularly to identify which customers are more at risk, and then feed this information to sales and marketing. Now, in addition to making ML more accessible to data analysts, it turns out that combining machine learning with certain types of data models can also lead to better predictions. For example, graph databases are often used to store complex relations between data in a graph model. These include things like knowledge graphs used by search engines, graphs of models of disease and gene interactions, and the relationship between financial and purchase transactions to aid in fraud detection, and product graphs for recommendation engines. Amazon Neptune is a fast, reliable, fully managed graph database service that makes it easy to build and run applications that work with these kind of graphs. Our customers tell us that they would like to apply machine learning to applications that use graph data to build things like better recommendation engines and generate more accurate predictions for fraud detection. But again, they lack the time or the skills. So today, we are announcing Amazon Neptune ML, enabling easy, fast, and accurate predictions for graph applications. Neptune ML does the hard work for you by selecting the graph data needed for training. it automatically chooses the best ML model for selected data, exposing ML capabilities via simple graph queries, and providing templates to allow developers to customize ML models for advanced scenarios. And with machine learning algorithms that is purpose-built for graph data using SageMaker and the Deep Graph library, developers can improve prediction accuracy by over 50% compared to that of traditional ML techniques. We are very excited about this one. We are not only integrating the power of machine learning into our own products, but we are integrating SageMaker into partners' products as well. We have integrated SageMaker Autopilot into Domo, Sisense, and Qlik, with Tableau and Snowflake coming early next year. In May of this year, we also added machine learning to Amazon Quicksight, the scalable, embeddable BI service built for the cloud. Quicksight ML Insights integrates with Amazon SageMaker Autopilot to enable business analysts to do things like anomaly detection and forecasting without any heavy lifting. Customers like Expedia Group, Tata Consultancy Services, Ryko Company are already benefiting from ML out-of-the-box experience with Quicksight. And it has a really great feature called Auto Narratives. It uses machine learning insights to tell customers the story of the dashboard using plain language narratives. Customers love these human-readable narratives. And they told us that they want to interact with their dashboards in a similar way. Ask new business questions in plain written language when the answers are not easily found in the data displays in their existing dashboards. Last week, Andy announced Amazon Quicksight Q to solve just this problem. Q is a deep learning-powered capability in Amazon Quicksight that empowers business users to ask questions in natural language and get answers instantly. To tell us more, I'd like to invite Dorothy Lee to give a look at how Q works.
Hi, everyone. Amazon Quicksight Q is a deep learning-based capability in Quicksight that is built using state-of-the-art machine learning and natural language processing techniques, allowing business users to ask data questions in plain language and get answers instantly. Let's dive into the capabilities of Q. Let's look at the scenario of a sales leader who's trying to find insights from her dashboard to inform next year's planning. Now my dashboard shows a summary of the data: sales per state, sales per product, and some yearly trends. But what if I wanted to understand something not in the dashboard, like the specific sales for the top 2 performing states, California and New York? Typically, to do that, I would need to cut a ticket or send an email to the BI team and wait for an answer. And since most BI teams are thinly staffed, that answer could come in days or weeks. Now with Q, I can simply type my questions in Quicksight and get answers. Show me last year's weekly sales in California. And Q provides an answer in just a few seconds. Now let's see how it compares to New York. And now Q shows a nice comparison of the 2 trend lines. It's interesting to see that in March, California sales had a huge spike, and that most likely got them to the top spot in the sales last year. Since Q uses advanced natural language understanding, you can ask the same question in multiple ways. For the same question, let's try asking a different way. Weekly revenue for California versus New York in 2019. And I get the same answer. Typically, users in different functions of the business, from sales, marketing, to finance, often have their own specific language. To understand everyday phrases in these different functions of the enterprise, we partnered with hundreds of teams at Amazon to collect a large volume of real-world data and train Q's models to understand these phrases. So there's no need for users to learn anything new. They ask questions in the natural way they already do and get answers. Let's continue from our sales example. I know that California was our best performing territory. I want to drill a little deeper and find the best-selling product categories in California. All I need to do is ask Q, what are the best-selling categories in California this year? Ah, it's kitchenware and outdoor. But it's a bit hard to see who are the laggards. How about we change the visual to show a bar chart? In the bar chart, I noticed that gaming is underperforming. Look how easy it was to get these insights. Getting started with Q is incredibly easy. Once you have connected Q with your existing data, Q automatically generates a knowledge layer that captures the meaning and relationship of your data, allowing you to start asking questions in natural language in a matter of minutes from all your data, and not just a specific data set or dashboard. And getting started is just the beginning. Q uses machine learning models to continuously improve with no machine learning expertise required. It's incredibly exciting to be able to reinvent BI using machine learning with Amazon Quicksight Q. Thank you.
Thanks, Dorothy. For a technology to be really impactful, it has to solve real business problems end to end. And Amazon Quicksight Q is one example of the impact machine learning can have when applied to a real business need. And the most successful customers are those in which domain experts and technical experts come together to move from idea to implementation to do just that. What makes a good machine learning problem? When we think about good machine learning problems, these are typically areas that are rich in data, impactful to the business, but that you haven't been able to solve sufficiently using traditional methods. Examples where our customers find these synergies are areas like product recommendations, improving code reviews, bringing more efficiency to manual processes, faster and more accurate forecasting, and fraud detection. When we identify these common use cases, we build AI services that enable companies to quickly add intelligence to these areas without needing any machine learning expertise. Some customers also ask us, instead of us having to stitch together these point products ourselves by writing code on top of your AI services, could you just solve the problem for us end to end? That's why we have launched several services that do just this. Amazon Connect is one example, a contact center in the cloud where we provide automatic voice transcription, sentiment analysis, and analytics using ML through contact lens. Amazon Kendra is an end-to-end intelligent search solution which can connect to multiple internal data silos and uses machine learning to create an accurate index which can be searched with simple natural language queries. Again, no ML experience required. Customers can build and customize their index and search interface without writing a line of code. And today, we are expanding the support for more than 40 more data sources via the Amazon Kendra connector library, including Atlassian, Jira, GitLab, Slack, and Box. Plus, we are releasing incremental learning, which is a capability that learns from user behavior to improve your results on an individual level. We also launched Amazon Code Guru that allows developers to use machine learning to provide automated code review, providing guidance and recommendations on how to fix some truly hard-to-find bugs and to locate the most expensive line of code in your app. By automatically profiling applications as they are running and making recommendations for how to dramatically reduce latency, CPU contention, and so on. And we just launched DevOps Guru to easily improve an application's operational performance and availability. Another area where our customers are asking us to do the heavy lifting for them to solve a business problem is anomaly detection. It turns out machine learning is really good at identifying subtle signals against a lot of noisy data. And there is data across a broad spectrum of industries where machine learning can be applied to help understand and catch anomalies before it's too late. Organizations of all sizes use data to monitor trends and changes in their business metrics in an attempt to find unexpected anomalies from the norm, such as a dip in a product sales or a sudden increase in qualified sales leads. Now, traditional methods for detecting these anomalies, such as setting fixed thresholds, are error-prone, leading to false alarms, undetected anomalies, and results that are not always actionable. The cost of not finding these anomalies in a timely manner can be really high. For instance, if a retailer prices something incorrectly on an e-commerce site, that product could be completely sold out before someone even realizes that there is a sudden spike in sales. So our customers asked, how can we make this process of anomaly detection for business metrics easier? To solve this problem, I am excited to announce that we are launching Amazon Lookout for Metrics. It uses machine learning to detect anomalies in virtually any time series-driven business and operational metrics, such as revenue performance, purchase transactions, and customer acquisition and retention rates. Lookout for Metrics detects unexpected changes in your metrics with high accuracy by applying the right algorithm to the right data. It's very easy to get up and running with Lookout for Metrics because it has 25 built-in connectors for data and alerts. It not only identifies the anomaly, but it also helps you find the root cause of these anomalies so that you can take quick action to remediate an issue or to react to an opportunity. And it continues to improve over time with the feedback as well. Retail customers can gain insights into category-level revenue by monitoring point-of-sale or clickstream data. Or an ad tech company can optimize ad spend by detecting spikes or dips in metrics like reach, impressions, views, and ad click. Now, let's take a look at how it works. It automatically retrieves the data you want to monitor from your selected data source from sources including various popular AWS services such as S3, Redshift, RDS, CloudWatch, and many other popular SaaS applications such as Salesforce, Marketo, Amplitude, Zendesk, and others. The service inspects the data and trains ML models to find anomalies using the best algorithm. It automatically scores and ranks anomalies based on their severity and helps you find potential root cause of the detected anomalies. Finally, it also prepares an impact analysis and sends you a real-time alert via your preferred alert channel. You can also automatically trigger a custom Lambda function whenever an anomaly is detected. So for instance, if something is selling out quickly on your site due to pricing inaccuracy, you could trigger an action to pull the product off the site until further inspection is done. Lookout for Metrics uses your feedback to continuously optimize its algorithm and improve its accuracy over time. You can visualize and review the details of these anomalies in the AWS console or retrieve them through an API. Amazon Lookout for Metrics has use cases that apply across industries. But we also hear from our customers that they want more solutions that are tailored and specific to their industries. To share more, I'd like to invite again Dr. Matt Wood.
Thanks, Swami. Machine learning is driving extraordinary levels of reinvention across virtually every industry. Take, for example, iHeartMedia, which uses machine learning on AWS to give its listeners real-time music recommendations across all of their media and entertainment platforms. Or, in the auto space, Lyft is gathering petabytes of data and analyzing it with Amazon SageMaker to improve self-driving systems. In finance, JP Morgan is improving its banking experience by adding personalization to its client interactions, including real-time coaching and recommendations for contact center agents so that they can better serve their customers. And we see reinvention happening in industrial manufacturing, where they are using data in the cloud and in nodes at the edge to rethink virtually all of their design processes on the production line from supply chain to finished product. At their simplest, industrial processes are a series of steps. But unlike most software, industrial processes are monolithic. They are very, very tightly coupled, which means that an equipment or process problem anywhere on the line can have a very, very large blast radius. As a result, maintaining throughput and cost goals in manufacturing and other industrial processes is a high-wire, tightrope balancing act. It is critical that these systems are monitored and that early warnings are given when something is off. Today, much of this is managed by process control with fixed thresholds. But these are brittle and don't take advantage of the vast amounts of data available from industrial systems. Now, last week, we announced new industrial-focused services that enable customers to apply machine learning to find and maintain balance in industrial processes, making it easier, safer, and faster to monitor and evaluate everything from manufacturing to power generation to agriculture. Together, these services help lower and widen that tightrope significantly. So let me walk you through them briefly, and then I'll show you how they all work together. So there are a lot of industrial companies who know that if they could use this data to do better predictive maintenance, they could save a lot of time and money. But some customers either don't have sensors installed, or they're sensors which are not modern or sensitive enough. And they don't know how to take that data from the sensors and send it to the cloud, or to build the machine learning models that detect a problem before it occurs. To help, last week, we launched Amazon Monitron, an end-to-end solution for equipment monitoring. Monitron comes with three things: a set of sensors, I have one here with me right here, a network gateway device, and a mobile app to track and resolve machine failures detected by Monitron on the shop floor. They work right out of the box. These are wireless sensors, and they're designed to have a 3-year battery life. They measure vibration in 3 directions, as well as temperature, and they can easily be mounted to equipment with epoxy. You easily mount sensors to any piece of equipment like motors, gearboxes, compressors, turbines, fans, and pumps, and they start taking vibration and temperature measurements straight away. The vibration and temperature data is sent automatically from the sensors to the network gateway, which then transfers the measurements to the cloud. You can view the sensor readings right away, directly on the mobile app. Monitron will also start building an ML model using the sensor data and use it to determine the normal baseline operating performance. If there is an anomaly in the machine sensor data, Monitron alerts technicians via push notifications to the app. It's a simple, end-to-end solution for predictive maintenance with no machine learning expertise required. And that's a big deal. It makes it much, much easier for companies to do predictive maintenance on their equipment. Now, there are other companies that we talk to that say, look, I have modern sensors that I'm fine with, and I don't want to build the machine learning models based on their data. I just want to send you the data, use your models, and have the predictions come back to me through the API so that I can integrate it with my existing systems. So we have something for this group of customers too, called Amazon Lookout for Equipment, a new anomaly detection service for industrial machinery. With Lookout for Equipment, you send the data to AWS, it gets stored in S3. The service can analyze data from up to 300 sensors per industrial machine and uses machine learning models to identify early warning signs that could be a sign of impending machine failures. The service pinpoints the sensor or sensors indicating anomalies, letting you respond even more quickly before the line is impacted. And if it finds anomalies, the service will send them to you via the API so that you can do your predictive maintenance. The anomalies detected by Lookout for Equipment can be integrated with your existing monitoring software, IoT Sitewise, or industrial data systems such as OSIsoft. And you can also set up automated actions to take when anomalies are detected, such as filling in a trouble ticket or sending an automated alarm that notifies you immediately of any issues. Customers who are also asking for help with using computer vision to improve industrial processes. Industrial manufacturing processes, they move fast and often require constant vigilance to maintain quality control. Determining if a part has been manufactured correctly or if it is damaged can significantly impact product quality and operational safety. You can try and do it manually, but it is super hard to do this accurately and to scale this on fast-moving lines. So last week, we launched Amazon Lookout for Vision, a new service that spots visual defects and anomalies in images using computer vision. You start by providing as few as 30 images of a baseline good state for machine parts or manufactured products. Then you can start sending images for cameras on the line straight away to identify anomalies. Lookout for Vision will spot differences between the known good state and any differences it detects, like dents on a manufactured part, a crack in a machine part, irregular shapes, or inconsistent colors in a product. If anomalies are detected, you can get alerts in Lookout for Vision dashboard, where it will highlight the portion of the images that differ from the baseline. Now, Lookout for Vision's machine learning models are sophisticated enough to handle variances in camera angle, pose, and lighting from changes in the work environments. In an industrial line, there are also lots of split-second decisions to make where you just don't have the time to send that information to the cloud and get the answer back. So many industrial companies try to use smart cameras that allow them to process video on-site at the edge. But the problem is that most of the smart cameras out there today are just not powerful enough to run sophisticated computer vision models. And most companies that we talk to, they don't want to rip out all of their cameras that they've just installed and put in different ones. That's why we built the AWS Panorama Appliance, a new hardware appliance that allows organizations to add computer vision to existing on-premises smart cameras. Here's how it works. You simply plug in the Panorama appliance and connect it to your network. Panorama starts to recognize and pick up video streams from your existing cameras in the facility. The appliance can then process streams of up to 20 concurrent cameras and operate computer vision models on those streams. And if you need to have more concurrently, you can just buy more Panorama appliances. We have pre-built models inside Panorama that do computer vision for you and that we've optimized by industry. So we've got them for manufacturing, construction, retail, safety, and a host of others. And of course, you can also build your own models in SageMaker and then just deploy those to Panorama. And Panorama also integrates seamlessly with the rest of the AWS and IoT machine learning services. The appliance itself is small but perfectly formed for industrial use. I have one here with me. It's IP62 rated, which means it's dust and water resistant. It's not as rugged as a Snowball Edge device, but you also don't have to treat this with white gloves. That said, it's 1U tall and half a rack wide with chassis points. So if you did want to mount it in a cabinet, you can. It has multiple Gig-E networking ports for redundancy or to connect cameras from multiple subnets. People are pretty excited about the possibility of having real computer vision at the edge, but they've also told us that, look, we're going to buy the next generation of smart cameras. And those smart camera manufacturers have told us that we want to actually embed something that allows us to run more powerful computer vision models right on those devices. So we're also providing a brand new AWS Panorama SDK, which enables hardware vendors to build new cameras that run more sophisticated computer vision models at the edge. This SDK and the APIs associated with it can be used to add a lot more computer vision power to cameras. We've done the work to optimize models for memory and latency so that you can fit more powerful models into what is often a very constrained space. The Panorama SDK devices will integrate with other AWS services. You can build and train models in SageMaker and then deploy them with a single click to all of your devices. Those devices will also integrate with SageMaker Edge Monitor and IoT services such as SiteWise for integration with existing systems. And we're already seeing a ton of excitement with partners across system integrators, devices, independent software vendors, and silicon providers working with us on this next generation of cameras. It's really exciting. So all these new capabilities are designed to help customers in industrial manufacturing to improve their process from start to finish. So let's see how they all work together looking at a manufacturing line. Building a product which is manufactured in its billions every year that many of us always carry in our pocket and has famously changed the way that most of us create and communicate. The humble number 2 pencil. Like many industrial processes, pencil manufacturing is a high-volume, low-margin game, which is automated in part, but still requires several manual steps to keep moving. So let's look at our pencil manufacturing line. Large compressors create the pencil wafers, and large-scale, high-throughput machines insert graphite, paint, and then sharpen the pencils. Industrial machines like these include dozens of individual sensors. Using Amazon Lookout for Equipment, the sensor data from this equipment is aggregated and analyzed using machine learning models, which are trained using your own data, but require no machine learning experience to apply. The ML models are trained to identify early warning signs of future operational issues by monitoring behavior such as how many reps per minute is considered normal for a machine. These are the proverbial needle in the haystack problems that, if found early, could help avoid expensive downtime. When the ML model detects a potential issue, such as a sudden drop in the rate of repetitions of this pencil wafer machine, the service will send text alerts so that you can send engineers to take a look or preemptively inspect the equipment for issues way before disaster strikes and the entire line is impacted and has to come down. Even with this sensor data, in lines like this, there is often bound to be blind spots. Equipment which either doesn't have sensors installed, or rotating equipment such as conveyor belts which move products between equipment and provide a potential point of failure. Monitron allows you to completely remove these blind spots by expanding the coverage of the sensors with an end-to-end machine monitoring solution. Process engineers can install Monitron sensors onto machines to start closing these blind spots in minutes. Like on this pencil sharpening machine, once the sensors are installed, you can start collecting data such as vibration and temperature, which is then analyzed automatically. And any early warning signals that deviates from the norm are flagged to staff on site through a mobile app, providing a completely closed loop for monitoring and remediation, which requires no machine learning or even AWS skills to set up and operate. Now, quality at every step is critical in lines like this. Even small imperfections at each step can compound, and they get more expensive to correct as they move down the line. Amazon Lookout for Vision uses machine learning to automatically evaluate quality at every step on the line. Using as few as 30 reference images, Lookout for Vision can identify even subtle defects, such as misalignments, dents, and scratches, sending alerts and notifications as soon as defects are identified before they move down the line and impact entire batches of products. Amazon Lookout for Vision processes the pencil's images from the cameras along the belt, and the model analyzes them for defects in real time. Each time it spots a lead that is out of alignment, it will record it and report the rate of defects via an online dashboard so that you can take action such as maintenance or the switching off of a line to stop more defects from occurring quickly. Now, of course, these lines don't exist in isolation. They are surrounded by entire teams of people, stacks of inventory, other lines, and dozens of other pieces of equipment and moving vehicles. In addition to monitoring each process, many customers have installed cameras to help monitor the environment as a whole. With the AWS Panorama appliance, these cameras just got a whole lot more useful. Now you can process video on site with low latency. So, for example, you can count and monitor inventory and analyze its movement through the site, or monitor the impact of process changes for improvements. Panorama can help transform your existing on-premises cameras into computer vision-enabled devices so that you can monitor all of these processes, remove bottlenecks, and make improvements to the overall supply chain. So with services such as Lookout for Equipment, Monitron, Lookout for Vision, and Panorama, you can use machine learning to add end-to-end monitoring and analysis to your industrial processes. Whether you're manufacturing cars, mobile phones, producing and packing food, collecting harvests, generating power, or yes, even building billions of pencils. We can't wait to see how our industrial customers reinvent their processes through machine learning using these services. So, industrial manufacturing is transforming in a very rapid way. And the same thing is happening with healthcare. A good example is to look at what Moderna has done in the last year or so, in really just the last 9 months. They built an entire digital manufacturing suite on top of AWS to sequence their most recent COVID-19 candidate that they just submitted. It has a 94% effectiveness, and they did it on AWS in 42 days instead of the typical 20 months that it takes. Novartis uses natural language processing to improve its ability to detect adverse events, a crucial part of delivering drugs safely to market. Cerner is using SageMaker to query large, anonymized patient datasets and build complex deep learning models to predict the onset of congestive heart failure up to 15 months before clinical manifestation. But even with all of this innovation, piecing together data that lives in silos and different formats to create this 360-degree view of patients or trial participants is really hard. And this is really the holy grail for healthcare companies, and they're just not there yet. This data is often spread out across various systems, such as electronic medical records, lab systems, and exists in dozens of incompatible formats. It often includes unstructured information contained in medical records like clinical notes, documents like PDF laboratory reports, forms such as insurance claims or medical images. And it all needs to be organized and normalized before you can start to analyze it. And gathering and preparing all of this data for analysis takes healthcare organizations weeks or even months. This often involves manually going through individual health records to identify and extract key clinical information like diagnoses or medications, procedures from notes, documents, images, recordings, forms, before normalizing it so that it can be searched. It's expensive and time-consuming to do well, which means analysis like this effectively remains out of reach for almost all healthcare and life sciences companies. And every healthcare provider, payer, and life sciences company is trying to solve the problem of analyzing this data. Because if you do, you can make better patient support decisions, operate more efficiently, and better understand population health trends. So today, I'm excited to announce the launch of Amazon HealthLake, a new service that enables healthcare organizations to store, transform, and analyze petabytes of health and life sciences data in the cloud. HealthLake transforms data seamlessly to automatically understand and extract meaningful medical information from raw, disparate data such as prescriptions, procedures, and diagnoses, reinventing a process that was traditionally manual, error-prone, and costly. HealthLake organizes data in chronological order so that you can look at trends like disease progression over time, giving healthcare organizations new tools to improve care and intervene earlier. Healthcare organizations can query and search data and build machine learning models with Amazon SageMaker to find patterns, identify anomalies, and forecast trends. HealthLake also supports interoperability standards like FHIR, the Fast Healthcare Interoperability Resource, a standard format to enable data sharing across health systems in a consistent, compatible format. So let's take a look at an example of how HealthLake can be applied to one of the most common chronic medical conditions, diabetes. Now, early detection and control of diabetes is critical to prevent the disease from getting worse and can lead to tangible improvements in the quality of life for patients. Data can help with earlier diagnosis and more fine-grained control over treatment. Healthcare organizations receive a lot of data for diabetic patients. For just one patient, there are hundreds of thousands of health data points from doctor's notes to prescriptions to blood sugar levels. And it's all stored in different silos in dozens of different formats and file types. It is a Herculean effort for healthcare organizations to organize all of this information for each patient and to normalize it for analysis. But with HealthLake, we can bring together all of this data in minutes with natural language understanding, ontology mapping, and medical comprehension. HealthLake can load prescriptions and identify if a patient has been prescribed a drug like metformin, accurately identifying and pulling out the medication's name, dosage, and frequency. Here, the information from a patient's blood glucose monitoring system can be added. HealthLake can load this structured data on an ongoing basis. And HealthLake also extracts information important from forms like physician's notes, insurance forms, and lab reports, and then adds it to the data lake so that it can be queried using a standard nomenclature. Separately, these are all just pieces of the puzzle, scattered around different silos. But when combined, we can start to get a much clearer picture of health. With HealthLake, you can bring together hundreds of millions of data points across millions of patients to paint a picture of the entire diabetic patient population. So now that this data is collected and normalized in HealthLake, it is immensely more useful. Let's see what we can do with this data to start to unlock new insights about this population. First, we can identify a subset of patients with uncontrolled diabetes with high blood sugar levels. So as a provider, we can adjust the treatment and avoid severe complication by better managing the disease. To do this, we can query the data directly from the HealthLake console to identify these high-risk patients using standard medical terms such as medications, diagnoses, or blood sugar levels. Next, we can use Amazon Quicksight to build a dashboard to visualize these data to get a more complete picture. We can compare this group of patients against others in a similar situation to identify trends and monitor patients to better understand how their risk factors change over time based on interventions or public health initiatives. We can also build predictive models which look forward. We can use SageMaker to forecast the number of new diabetic cases year over year, informed by millions of points of health data, providing a quick, easy way to identify health trends in patient populations. What was once just a pile of disparate and unstructured data is now structured, easily read, and searched. And for every healthcare provider, payer, and life sciences company, HealthLake helps them get more value out of their health data by removing the undifferentiated heavy lifting associated with storing, normalizing, organizing, and understanding their data so that they can answer important questions which help their patients and improve the quality of their care. So to talk more about how they're applying machine learning to reduce this complexity and provide better care, I'd like to invite Elad Benjamin, the General Manager of Radiology Informatics at Philips, to talk more about his work. Thanks a lot.
Hi, everyone. My name is Elad Benjamin. I'm the General Manager of the Radiology Informatics business at Philips. When you envision how you'd like healthcare to be, what do you think of? For me and many others, what comes to mind is quality. And what is quality in the context of healthcare? It's the optimal meeting point of speed, accuracy, and cost. The holy grail of medicine is to reach diagnosis and deliver treatment in the least time possible with no mistakes at the lowest cost. We have the opportunity to get closer to the holy grail by synthesizing data in new ways. And today I'll talk specifically about data analytics, machine learning, and computer vision. Part of the difficulty in healthcare today is the abundance of data being generated. Quantity, diversity, and multi-source. Imaging, monitoring, genomics. Physicians need to work through those data silos, and it's getting harder for them to diagnose and treat. At Philips, we're trying to help tackle these challenges in a number of ways. One is HealthSuite. HealthSuite is a foundational layer, a cloud-based data platform that consolidates patient records, data from wearable or home-based remote medical monitoring equipment, information from insurance companies or healthcare organizations. The HealthSuite Clinical Data Lake runs on AWS and brings high-volume clinical data together while meeting regulatory requirements. HealthSuite includes dozens of AWS services from the edge to the cloud, providing the cloud foundation for IoT and remote connectivity for smart diagnostic systems, operational analytics for optimizing workflows, scalable telediagnostics for remote and emerging points of care, and cloud packs for integrated diagnostics. A specific example within HealthSuite, we just announced the availability of the new Analyze AI training service. It's a multi-tenant service that provides functionality to submit and manage CPU or GPU-based AI, machine learning, and deep learning training jobs. It uses Amazon SageMaker as the execution engine in the background. The training service offers users the ability to configure the custom compute environments and permitted compute targets. It helps users submit and manage the long-running training jobs connecting to an existing Git repository and associating its execution with required compute environment and targets. Within radiology, in order to advance precision diagnosis, Philips is applying machine learning and AI tools to improve diagnostic system, realizing first-time right diagnosis through clinically relevant and intelligent diagnostics. optimize workflows, connecting and integrating workflows to drive operational efficiency, integrating insights from imaging, monitoring, laboratory, genomics, and longitudinal data to help create clear care pathways, assisting with decision-making at pivotal moments of the patient's journey. We build machine learning models using Amazon SageMaker to draw insights from the data. And in the future, we may use Amazon Transcribe Medical and Amazon Comprehend Medical to integrate additional data sources and store them in a data lake built on AWS. Using AWS machine learning and AI services to streamline building, training, and deploying our models makes sense. AWS builds these services to run at scale and cost efficiently, freeing our data scientists to focus on higher value activities. Philips and AWS share a common goal to demystify data science and artificial intelligence methods and accelerate their use to extract new knowledge from health data to improve healthcare delivery. At Philips, we're disrupting healthcare by bringing together the right information, the right tools to make the right decisions for patients and have providers really do what they signed up for, taking care of those patients. We expect to see AWS machine learning and AI services continue to be further embedded throughout the broader Philips organization. There are a number of business areas that will benefit from accelerated AI adoption, from image-guided therapy to sleep and respiratory care, remote patient monitoring. The unlocking of big data using ML and AI tools will support the fundamental shift from volume to value-based care and to a precise diagnosis for each patient. Thank you very much.
Thank you, Elad. Finally, the last tenet that I'm going to talk about is giving builders the ability to learn continuously. Training and education, especially in emerging areas like machine learning, enables teams to keep up with new technologies and fosters innovation throughout an organization. At Amazon, one of our leadership principles, and my favorite one, is learn and be curious. We encourage everyone, including our builders, to try new things, learn new technologies, and stay curious about the world around us. This is one of the reasons why Amazon has been at the forefront in adopting disruptive technologies like machine learning before they were even mainstream. In fact, early on in our adoption journey of machine learning, we developed a machine learning university that we have used for over 6 years to train our engineers on ML. Now, to help others benefit from this content, we have made it available for free for anyone to learn and launched a certification for machine learning on AWS. And developers can't get enough of it. Based on this demand, we also develop content from massive open online courses such as Udacity, Coursera, and edX to bring practical applications of machine learning to more people. Also, to make more complex machine learning concepts like reinforcement learning, deep learning, and GANs more accessible, we created our educational devices like DeepRacer, DeepLens, and DeepComposer. Over the years, programs like DeepRacer, our fully autonomous 118-scale race car driven by reinforcement learning, have built a loyal fan base, and the team continues to bring new experience to our DeepRacer leagues. And over 150 customers globally have trained thousands of developers. These include Capital One, Moody's, Accenture, DBS Bank, JP Morgan Chase, BMW, and Toyota have held events for their workforce. Now, let's take a look at the fun we have had with DeepRacer last year and a look ahead at what's next with DeepRacer this year.
What am I getting myself into?
Welcome to another AWS DeepRacer Underground.
Oh wow! OMG!
some exciting stuff coming from Deep Racer. Over the past few years, machine learning has come an incredibly long way. The barriers to entry have been significantly lowered, enabling builders to quickly apply machine learning to their most pressing challenges and biggest opportunities. This was never more apparent than in the wake of the pandemic. Our customers needed to move faster than ever to respond to the changing world. They applied machine learning to create new ways to interact with customers, reimagine the way we work and learn, and automate business processes to react faster to customer needs. They applied machine learning to tracking the disease, finding new ways to care for patients, and to speed up vaccine discovery. They were able to do all this because their builders were free to harness the potential of machine learning, free to invent, to build remarkable technology on top of it. Enabling this freedom is what our team is passionate about. It's what drives our own innovation, and it's why we push out new features nearly every single day. In fact, we have so many things launching during reInvent that even between myself and Andy, we are not able to announce them all. So be sure to check out the more than 50 ML sessions we have available throughout the event. Thank you, and have a great rest of your reInvent.